Welcome, everybody, to another Crow Canyon Archaeological Center webinar. Crow Canyon is proud to partner with the Department of Anthropology at Washington State University to present Thinking Like an Archaeologist with Dr. Tim Kohler. My name is Mark Varian. I'm the Executive Vice President of the Research Institute at Crow Canyon, and we're really happy for all of you who have tuned in to tonight's webinar. Want to thank Dylan Schwint and Taylor Hasbrook of Crow Canyon, who make the technical aspects and logistical aspects of these webinars happen. It's become a really successful series, and a lot of the credit for that goes to them. Crow Canyon is also grateful to the Colorado Humanities and National Endowment for Humanities for their CARES Act support last year. And by support, I mean funding. These grants helped us maintain operations and create new programs like this webinar series. So we're very grateful for those partners. A few logistics for tonight's webinar. If you haven't done one before, if you're watching this on Zoom, you can move the talking heads and drag them to one corner of your screen so it doesn't block out Tim's PowerPoint presentation. And then we encourage you to ask questions using the Q&A button. We'll get to those questions when Tim finishes his talk, so we'll do that at the end of the webinar. If you're having any difficulties with Zoom, just head over to that address on Facebook and you can watch this on Crow Canyon's Facebook page. We also record these talks and publish them on Crow Canyon's YouTube site at crowcanyon.org/YouTube. All of our webinars are there, so I'd really encourage you to go to that address and check out any that you've missed. There also might be parts of tonight's talk that you want to go back and look at in more detail, and these YouTube recordings give you the ability to do that. Crow Canyon Archaeological Center. It has a long history, but its incarnation as the Archaeological Center began in 1983. This is a picture of our campus with Sleeping Ute Mountain in the background. We're located just outside of Cortez, Colorado, in the southwest corner of the state. And our mission is to empower present and future generations by making the human past accessible and relevant through archaeological research, experiential education, and American Indian knowledge. If you've never been to our website, there's all sorts of resources there to learn more about the past and learn more about the center. So go to www.crowcanyon.org. The Crow Canyon Archaeological Center acknowledges the Pueblo, Ute, Dene, Hickory, Apache, and Paiute people on whose traditional homelands we work and reside. We're grateful to all Indigenous people who continue to preserve and protect cultural traditions, maintain ancestral relationships, and steward these lands. The work at Crow Canyon would not be possible without recognizing and honoring the many generations of people that we learn from every day. There's some great upcoming webinars. One of those is by Tim Wilcox, who's an Indigenous archaeologist. He's Dene and Pueblo, been working at Crow Canyon for several years now and is working on his PhD at Stanford University. This webinar is co-sponsored with the Hisatsinom chapter, which is the local chapter of the Colorado Archaeological Society. And that chapter just does incredibly good work in this community to conduct archaeological survey and to do many activities that promote the preservation of cultural heritage resources in this part of the world and elsewhere. Tim will be presenting on the emergence of Navajo polychrome ceramics. And I've talked to him about this. It's really fascinating research, so you'll really want to be sure to tune in on that one. Then we have a new type of webinar coming up, really exciting. It's a two-part mini-series that will happen on 2 Thursdays, February 25th and March 4th, and featuring Craig Childs, the well-known author whose most, not all of his work focuses on the Southwest. The title of the two-part series is Return to House of Rain. And it'll be more than just Craig talking and showing a PowerPoint. There'll be videos of him out on the landscape. So it's going to be a really exciting series that you'll, and if you've ever heard Craig talk, it's sort of like performance art. it's really exceptionally engaging, just as his writing is. So you'll be sure to want to tune in for those too. COVID has been hard on all of us, and it's been especially hard on Indigenous peoples whose societies really revolve around community and large kin groups. Those Four Corners tribes can use help getting through this COVID period, and these are all funds that you can contribute to help those communities. And this is a place where if you don't have a pen or pencil handy, you can go to the YouTube channel later and pull up this slide and get these addresses and provide assistance to the Indigenous communities of the Four Corners. Okay, tonight's webinar, Thinking Like an Archaeologist by Dr. Tim Kohler. Tim he says he's an archaeologist at Washington State University. I think he's actually a Regents professor there, who's been working in the northern Southwest for over 40 years, beginning with the Dolores Archaeological Program, which was directed by David Bretternetz and Bill Light, and where I worked and first met Tim. During the DAP, he became interested in what happens to societies as populations grow and the effects of this growth on their habitats. After the DAP, he collaborated on a project with the National Park Service in Bandelier National Monument, where he could see firsthand the effects of the major transformations in the economy and ritual system that began in the late 1200s. His long association with Crow Canyon Archaeological Center includes his service on on our research committee from 1986, not long after we were founded, to 1990, and he's currently a member of the Board of Trustees. He directed the Village Ecodynamics Project, arguably one of the largest archaeological projects ever conducted in this country, or at least largest funded by the National Science Foundation. And he included Crow Canyon as a key participant in that project. He's also the lead author on the 6th assessment report of the Intergovernmental Panel on Climate Change. Publication of that report is expected in 2022. And finally, he's a member of the external faculty of the Santa Fe Institute. Tim has received too many awards to be listed here, but he did win the 2010 Society for American Archaeology Award for Excellence in Archaeological Analysis that recognizes innovative technical analyses that make an enduring and significant contribution to the discipline. And in 2019, he was the recipient of the Society for American Archaeology Presidential Recognition Award for sharing archaeological research with the contemporary world. And this webinar is an example of both of those awards. His incredible sophistication in technical analyses and his ability to share that with all of us. So we're very grateful to have you, Tim. And Taylor and Dylan, I took away my bar to stop sharing. Can you turn my screen off, or do I need to get that bar back? Thank you.
There you go. It should be done sharing now.
Thank you. Appreciate your help.
Thank you, Mark. Let me try and share my screen here and see. Oh, now I don't have a bar for sharing my screen. Wait a minute. Here we go. Okay. Does that work? Can you see that?
You're coming through clear.
Wonderful. Thanks so much, Mark, for that introduction. Mark has been one of the people that I've worked with, gosh, for 40 some years, and that probably doesn't even count Dolores, along with Bill Lipe and Ricky Lightfoot. He's one of my oldest or longest colleagues in the Southwest. And he said a lot about how we've intersected over the years at Crow Canyon DAP, so I won't say anything more, but I do want to say one more thing about Crow Canyon, because one of the things I've learned about archaeology in the last 40 some years is that there's no substitute for long-term research in a particular time and place. You keep adding to what you know, but this kind of happens in a non-linear and a super linear way when you work in a place for a really long time, because the new things you learn can be connected with so many other things you learned previously. that the returns start to become, we could say, superlinear. That just means that the new things you learn can be connected and they're very rich. They network with the other things you learned. So they have large paybacks. And that's what Crow Canyon makes possible. And I hope you'll help them as they are creating what I really consider to be the strongest archaeological data set in the world for studying processes like wealth inequality, violence, the effects of climate change on society, all these things that I'm really interested in. So that's what Crow Canyon makes possible. And I'm going to talk about a couple different projects today. And one of them will use a data set that includes data generated by Crow Canyon Research. But in general, they're sort of bigger topics. And you must wonder, if not even worry about my title. But I chose it because I didn't want to emphasize what we're learning about some particular cultural sequence in prehistory. I've given a lot of talks, and I love to do it, where I talk about the pre-Hispanic history of the Central Mesa Verde area, for example, and I can do that for hours. But I'm hoping to convince you that there's some attributes of the way that we archaeologists think when we try to understand what happened in prehistory that can be usefully applied to our present circumstances. So let's go. One of those attitudes is that, frankly, in archaeology, we have this nonstop interest in what lies beneath. And I mean that really in two different ways. One of them is very sort of literal. What happens if we dig just a little bit deeper? Mark will remember an episode from Grass Mesa Village, a Pueblo I site not far from Crow Canyon that dates to mostly to the 800s. And one of the excavators there accidentally went under the floor of one of the rooms in one of the surface rooms at Grass Mesa and exposed a huge bone. And it turned out that it was a muskox. And that muskox had died, who knows, 17,000 years before Grass Mesa was occupied by Puebloans. So there's always that fascination with what lies beneath. But I mean it too in sort of a more metaphorical sense. Can we think about why things happen in prehistory? Try a little harder and understand more about why things happen rather than just trying to describe what happens. So that's one attribute, one attitude. The second thing is that archaeologists are really stuck on the importance of the long term. And I happen to think that this is endearing and valuable. Slow processes are really important. They might take a long time to manifest themselves in real change, but nevertheless, they can't be ignored. And that will be one of the things I'll be talking about in my second part of my talk. The third attitude that's typical is what I'm going to call big patterns. This is kind of big, but archaeologists have a hard time picking up really subtle things in the archaeological record. What we see best are the kinds of things, big patterns, the sort of things you'd see if you were flying 30,000 feet above the landscape. And you can easily tell where the cities are, where the towns are, where the forests are, where the fields are. But sort of the details of what individuals do and why they do it are kind of washed out. This is what physicists would call coarse graining. So archaeologists deal with a very coarse-grained record for the most part. And I don't think that's all bad, because I think it really makes us attend to the big picture. Another thing is, of course, why. And so archaeologists were probably the most annoying of all kids. I'm sure I was, never stopping to ask why, and that why things happen in prehistory remains important. So I'm going to describe two recent studies that I hope illustrate some of these points. I wonder if any of you happen to see the Netflix movie, The Dig, which is on right now and featured on Netflix. And it shows a ship burial of a very important Anglo-Saxon man dating from the early 600s AD in Suffolk, I think. And he had, all sorts of gold jewelry and a fancy sword and so forth. And when you have numerous priceless objects adhering to somebody who's buried in a big ship or in a pyramid, there's no doubt that there was a great deal of inequality in wealth and power existing in that context. But the archaeological record holds a lot of clues to differences in wealth in situations that are not so clear-cut. Objects coming from long distances, houses in favored spots, such as in the center of the settlement, or next to a ritual structure. And one of the things that I'm going to be talking a lot about is house size. In society after society, ethnographers have found that wealthier people live in bigger houses. That probably no surprise. We see that in our society as well. And so one of the ways we can measure wealth inequality in prehistoric societies where we don't have textual records is to look at the distribution of house sizes in a settlement. And when you can do that, you can then construct something that I'll be talking a lot about called a Gini coefficient. That's G-I-N-I, and I promise I won't get technical about this. The Gini coefficient is simply a way of measuring inequality. It could be in income, it could be in wealth, it could be in almost anything else. We'll see some examples of it shortly. 2 or 3 years ago, with an archaeologist at Arizona State University named Mike Smith and a bunch of other people that you'll see on this slide here, we put together more or less all the measurements of wealth inequality that we could find for well-dated sites all over the world. And you can see where these sites came from. And they're not very numerous, and there's huge gaps in the map. You can see North Africa is a big problem. All of South America is missing. South Asia is missing, and so forth. So we are, in fact, right now trying to get another grant to fill in some of the blanks on that. But what we were attempting to do was just to get sort of a broad scale description of what happens through time in terms of wealth inequality. And what we eventually came up with, well, there was a book that was published that was called 10,000 Years of Inequality. And then we pulled out the last chapter of that book and spruced it up a little bit, and we were able to publish it in Nature. And that was that publication I was showing you in the previous slide. But in the Nature publication had a couple graphs that I want to show you and talk about them just a little bit. This one has time on the x-axis here. Minus 8,000 means 8,000 BC, 2000 is 2000 AD, our present time. And these are these Gini coefficients. You could think of them, if you're at all familiar with statistics, you could think of them as variances. They show how different house sizes are in a particular settlement or in some limited chunk of time and space. And so 0.2 means that they're all very similar. There's not much differentiation in house sizes. 0.8 means there's a great deal of differentiation. So perhaps, for example, you could have 1 or 2 really elaborate large houses and the rest very small, and that would yield a higher Gini than the case where they were all the same. What we saw in the old world and the new world in the sample that we had, which by no means we consider a representative sample, it's just what we could find, is that in the old world, which is all in blue, of course, the record's starting quite a bit earlier and gradually increasing through time until we get to places like Pompeii, which is early Roman Empire, Kahun, which is Middle Kingdom, Egypt. And you can see these are quite unequal. Then we have the New World. These are all calendar years down here, with the record starting later. And this is a Mesoamerican formative period site. We have Teotihuacan up here. Ozette, which is not terribly far from where I'm talking to you from on the coast of Washington State, which is, like 1600, 1500 AD. This is interesting. It shows that in general, something that we didn't know is that wealth inequality, at least measured this way, was higher in the old world than it typically got in the new world. But it's still kind of confusing because these things start at different times. So we tried to sort of reproject the series. And that's what we see here in the bottom slide. And the reason this is different is that now the x-axis down here is delta years. And delta years is simply a re-expression of years AD, in which we take the actual date of any particular group of sites. Here we have Central Mesa Verde T2, for example. where over here we see that's dating to, who knows, maybe 1000, something like that. And here, in terms of delta years, we're subtracting that 1000 figure from the time at which agriculture arrives locally within this area. So since this is about 1500, that means we think that agriculture arrived in this general region in northern San Juan 1500 years before Central Mesa Valley P2, so it has 1500 there. So if we re-express them in this way, what we see is that there's a long early development of wealth inequality in the old world and the new world that's really on the same pace and going in the same direction. And it's not until you get up to about 2500 delta years, that is, say, 2500 years after the local adoption of plants, domesticated plants and animals, that the old world begins to sort of get higher Ginies, that is more unequal in terms of wealth distributions than the new world. And it stays that way. And it gets very much so later on. And maybe that's not surprising because in the old world, you have the development of things like iron and complex seagoing vessels and all sorts of things that you don't have in the new world that add to wealth. But we were interested in why you have this little bit of pulling away of the old world versus the new world right here. And it turns out that right in here, beginning about 2,500 years ago or so, and then going on all through this, you have the beginning of use of large domesticated animals, especially cattle, oxen, but eventually horses. And of course, you also have contributions from things like sheep and goats and pigs. You have all these suite of domesticated animals that you never have in the new world. And we think that the first and most important contribution of those was to make it possible to go much further from your residence to do an extensified form of agriculture. And you could use oxen for that, and you could plow much more and bring much more back and have much more return than you could ever do in the new world. Remember that in the new world, we never had, except for South America, and we don't have any sites in our sample from South America, you never have large domesticated mammals. You have dogs, you've got guinea pigs, you've got turkeys, but you're not going to get any of those to pull a plow. So we think that that's the original reason for the differentiation in wealth between the old world and the new world. Now, there's many lessons that we can draw from this before I go on, but I can't go on it too long because I'll run out of time for my second case. But notice that the highest Ginies we ever compute are something along the order of 0.6, maybe for Tikal, which is a classic period Maya site, maybe for Kahun, which is a Middle Kingdom Egypt site. And those seem pretty high, but if we were to compare them with what we have in the United States today, we have wealth inequality, according to Ginies, of about 0.8 or 0.85. So they would be off the scale here. So that serves to show us that, at least by this measure, the U.S. today is more unequal than ancient Rome under the emperors or ancient Egypt under the pharaohs was, which I think is surprising for most people. Now, granted, I think we should think about these as being approximate measures. When we measure 0.85 of wealth inequality for the United States, we're not basing it on house size, they're basing it on total wealth. And so that's going to probably exaggerate or raise the levels of the Ginies. But it's something in which we can say that, yes, here's something that we can measure about the same in the archaeological record. We can compare it with what's going on with the United States today and other places in the world today. And that's powerful and interesting. Now, you might say, well, maybe in contemporary societies, there's no relationship between the floor area and, say, the wealth. And you could be right. We're looking into that. I think you're wrong. But this is a graph that we found just recently that shows across all the United States, averaged, so this is very aggregated data, that as GDP increases, so you could think of this as wealth, since it's per capita, average wealth, that the floor area also increases in a very strong and very linear way. Now, granted, there's all sorts of weirdness going on in the Great Depression on up through the end of World War II, where everything gets a little bit wonky. But those aside, it's a strong linear relationship. Now, so we're going to try to peg down the contemporary relationship between house size and wealth inequality in the next round of research on this. But that's one way in which we can shed some light, give some perspective on what's something that's going on in the world today from the archaeological record. The second case study is also a case where I want to try to use something about the past, but not to put the present world into perspective, but try to put the future world into perspective. And I think it'll show, at least I hope it does, something that I argued at the beginning, that slow processes are really important. And it's also important to try to see big patterns, whereas in our day-to-day lives, we tend to get lost in the details. So here we see an archaeologist working out at the Haney site again. And this is really a lot of what we do in archaeology, and it's absolutely essential, but you can see it's highly detailed work. And the challenge for archaeology is how to get from that detailed work to a big picture that would be something in which we can see analogies with the present and even perhaps with the future. So the next case study shows another way, at least another attempt to do that sort of thing. And about 4 years ago or so, I got an email, as did many other archaeologists, asking us to contribute to a crowdsourced prehistoric atlas of the world. And this project was called Archaeological. And we were asked to code for the prehistory of land use through time for any of the 146 different regions shown on this map here, for which we felt we had expertise. About 250 archaeologists responded to that call. I myself coded the information for the U.S. Southwest and the U.S. Southeast. My first field work was in the Southeast, and I felt competent to code those two areas. You can see the yellow areas are areas where lots of people felt competent to code. Then there are some areas that had very few people feeling competent to code, and so that's a bit of a problem. But in general, those areas are areas that had relatively low population. So if there's an error there, it's probably not going to make a huge error in the worldwide picture. So you can see that, as you might expect, the areas of the world today that are fairly populous and have quite a bit of wealth and have had a lot of archaeological work are the areas in which lots of people felt competent to code. And then there are other areas where those things are not true. So one of the important outcomes of this project, and this actually is not the project I want to talk about, it's just a preamble to the project I want to talk about, was a global summary of land use trends through time. And that's what we see at the top here. And it shows, which is really of no surprise to any archaeologist, I think, that over the last 10,000 years, and these are before present, so that's 10,000 years ago, this is the present, that foraging has been on the decline, strongly on the decline after about 6,000 years ago. At the same time, pastoralism was beginning to ramp up. Extensive agriculture was beginning to ramp up. Pastoralism was beginning to ramp up. Intensive agriculture was starting to ramp up a little bit more slowly, really getting sort of off the ground more like around 5,000 or 4,000 years ago. Well, for us, the time of 6,000 years ago is a particularly interesting time because we're going to use that as sort of a benchmark for comparison in the next study. And so I want you to be real cognizant of what's going on at 6,000 years ago. We can see that foraging is starting to decline, but there's still a lot of it, still a lot of hunter-gatherers in the world 6,000 years ago, which is mid-Holocene. There are some pastoralists. There are some fair number of extensive agriculturalists and a few intensive agriculturalists. So a real mix of subsistence modes across the world at that point. And you can see that illustrated for particular regions here. Here we go. Okay, so here's the decline of foraging. You can see that at 6,000 years ago, look for browns. Foraging was in rapid decline in all those areas that are brown 6,000 years ago, but hadn't really started to decline in most of the Americas yet, or in most of Northeastern Asia, or in Australia, or in southern portions of Africa. But by 6,000, look over here, the extensive agriculture, which is non-intensive, so that would be like Sweden agriculture, would be like what we think about with horticulturalists, was beginning to increase by 6,000 in these areas that match this color. Intensive agriculture was beginning to increase in these areas here, and pastoralism was beginning to increase in the same areas. Not much urbanism, just a little bit in the Near East and Mesopotamia and in this valley. Otherwise, lots of hunter-gatherers. So we're going to take this 6,000 BP date about what's happening in the world and run with that, because for one thing, we have, since it's the mid-Holocene, we have good climatic reconstructions for that period, so we can tell what the temperatures and the precipitation patterns were in these various areas at 6,000 years ago, which leads to the next paper. And this looks complicated, but I hope I'll be able to explain it to you. On each of these little blue graphs here, the x-axis is always showing us mean annual precipitation increasing as we move from this direction to this direction. And the y-axis is always showing us the mean annual temperature going from, say, -10 down here, very cold, those would be polar regions, to 40 degrees, and that would be practically no place on Earth. If you wanted to see what the distribution of the land surface on Earth was relative to mean annual temperature and mean annual precipitation, it looks like this. The blue areas are not represented, or very low representation. The red areas are represented a lot, so that means that there's a lot of areas with -10 mean annual temperature and low precipitation, so those would be polar regions. And there's a lot of area that has high mean annual temperatures and not much precipitation. Those would be places like the Sahara. And then there are places like moving over here where you have high mean annual temperature, but also high mean annual precipitation. And that would be places like the Congo, places like the Amazon basin. So this is what's available in the world. But let's look at where people actually live, because the densities of people are a real non-random selection of what's available in the world. Humans now live in these areas here. We call this the human niche. And we're looking at it on this axis, it's the human temperature niche. If we're looking at it on this axis, it would be the precipitation, this axis is the precipitation niche, this axis is the temperature niche. So what we see is that there's a big mode. There's a lot of people living between about 10 or 11 degrees, and this is all centigrade, mean annual temperature, and about 15 or 16 or even 17 degrees mean annual temperature, right? And then as temperatures get higher than that, there's a secondary mode right around in here, and that would represent places mostly in South Asia. So Calcutta would be up here someplace. If we were going to look at Chicago or San Francisco or Washington, D.C., they'd be right down in here someplace. So if we project backwards where people were living through time in terms of their temperatures, we can see that about 500 years ago, this comes from a data set, by the way, called the Hyde data set. which stands for History Database of the Global Environment, which was put together by some Dutch researchers a few years ago. So 500 years ago, the distribution of humans looks, sort of similar to what it does now, although slightly more compact. But here's the big thing, and this is where the archaeology came in, and this is where we use the Archaeoglobe. This shows that 6,000 years ago, in the middle of the Holocene, people still were densest in this same area that is roughly, say, 9 to 12 or 13 degrees centigrade. And there's some action in other places too, but people are very concentrated right in here. So you might ask, why the heck is that anyway? Because remember that people at this time were a real mix of hunters and gatherers and horticulturalists and intensive agriculturalists and hardly any urbanism at all. You might say, well, maybe it has to do, maybe we have this distribution and we're going to call these distributions generically similar here. Maybe we have that because that's where the soils are most fertile. But if you look at the map of soil fertility, or this is just really a graph of where the soils are most fertile, it doesn't look like any of these three. So the people are not where they are because of soil fertility, at least not primarily. You might say, well, they're where they are because of net potential productivity or net primary productivity. But that looks very different too. So that the distribution of primary productivity doesn't seem to explain where humans are now or where people have been in the past. I'm sure that neither of these things is irrelevant. It's just not, you couldn't say that that's the main driving force for these distributions because they look so different. So let's look at this in another way, dig a little bit deeper. And when we look at here we have mean annual temperature increasing, and here we have population density on this axis. And if we look at where people were 6,000 years ago, according to Archaeoglobe, we'll ignore the Hyde reconstruction because I think Archaeoglobe is better. It's this black line here, and comes up like this, and you see this mode here around 10 degrees or a little bit higher, and then it falls down, and you have a secondary mode about 24, 25, something like that. That's more or less what you've already seen and expressed in a different way in the previous graph. And here's the current distribution right here. This blue line, it's kind of hard to see in all there, but trace it along like there. You have sharp mode around 15 for where people currently are, and it falls down, and you have a secondary mode, mostly South Asia, for higher temperatures around 25 or so, and then it drops off very quickly after that. So if we want to generalize this blue thing here, this blue line where people are now, and have a sort of population model, it would be this dotted line here. And it just smooths that other blue line. Goes up and down like that. Secondary mode, South Asia, like that. Okay, fine. And the other distributions here for historic distributions look sort of like that too, more or less. But then this line here is very important, and it's very different. What we've done here is to take the current distribution right here and done two things to it. First of all, we're going to move the population distributions ahead 50 years in a spatialized way. So people grow in place where they already are according to the projections of the United Nations. And if you want to know the details about which projections and so forth, it's easy to find this paper. It's freely available online. And then what we did was we moved the climates 50 years ahead. Now, to do that, you have to decide which climate scenario you want to use. And so what I'm going to show you here is what is often called the business as usual scenario. That means we continue to produce a lot of carbon dioxide. We don't do too much to mitigate it. And this is called RCP 8.5 by people who do this for a living. And so that's a pretty bad scenario. But there are other scenarios that we explore in the supplemental materials to this paper that aren't so bad, but still are generically similar to the 8.5. What you see in that is that most people by that time if population grows in place at current rates and the climate changes according to the business as usual scenario, are going to be living in places with a mean annual temperature of 30 degrees, say 29 degrees. That's shocking because there's hardly anybody in the world today living in temperatures like that. We get temperatures like that primarily in places like the Sahara. So it's not a place that you would really like to be. We can look at this in a different way. Right here on the right, we see this is the Archaeoglobe reconstruction for 6,000 years ago. This is the Hyde reconstruction for 6,000 years ago. This is 500 years ago. This is 300 years ago, and this is current. And what this shows, and the reason what this shows is the temperature that the average person, the mean temperature experienced by a human being in different periods. So what this does is it moves the climate ahead 50 years for this one. It moves the population ahead 50 years for this one. And it shows that the mean temperature experienced by people is going to be something like, say, 25, 26. And the reason there's different estimates here is because of different projections for the climates. And that's very different than any of these. And in fact, what you can conclude is that the mean temperature experienced by people in 50 years, in 2070, is going to change more in just those 50 years than it has changed in the last 6,000 years, which seems to me to be pretty shocking. Here's another way of looking at it. If we look at the places today that have mean annual temperatures of greater than 29 degrees Celsius, they're mapped in black right here. That's it. A few places are on the Arabian Peninsula, but mostly down here in the Sahara. If we move that forward 50 years, then all the places that are mapped with the slanted lines here, plus the places with the black solid, are going to be experiencing mean annual temperatures of greater than 29, which are equal to or greater than 29, which is really at the very limits of human biological capacity to endure, not something that people would choose to live in. So one more thing we can do with this, and then I'm going to change the pace a little bit, is to look at how far, not in geographical distances, but in niche space, how far different parts of the world are from the human temperature niche, the sweet space, the Goldilocks zone between about 11 and 15 or 11 and 16 today. And so every place that's right in the zone is going to be a dark bluish green here. And we see large swaths of Eastern North America in there, large swaths of Europe, China, some of South Africa, some of South America, portions of Australia. Then we do the same exercise for 2070 under RCP 8.5, and the green areas are still showing places that are in the sweet spot, in the human temperature niche. It's been our favorite place to live for at least the last 6,000 years. And these are all the greens, and the greens have shifted forward, shifted north just a little bit here, you can see. And then we also have areas that are very much different than they were in the earlier map here. The trick that is easy to do then with a geographic information system is to difference these two maps. And we can say what places are changing in terms of their desirability as we move from the current 50 years ahead under RCP 8.5. And we see that the areas that are red here are the areas that are moving farther out of the human temperature niche. And the places that are green are moving farther into the human temperature niche. So we can see that Canada is doing pretty well, for example. And Northern Europe's doing pretty well, look at that. England's doing pretty well. Even Iceland's doing pretty well. But then, on the other hand, there are large areas, including in southeastern U.S., that are not doing well at all. They're moving outside or at least out away from the desirable zone. And that includes large portions of Africa, large portions of South America, the Amazonian basin, huge portions of South Asia, portions of South China, most of Northern Australia, a lot of Indonesia, and so forth. So that's pretty sobering. You know, I think you could look at this map and say, well, maybe if you're living in Canada or Saskatoon or something like that, maybe this isn't such a bad thing. Maybe those will be the climate winners. And I guess that is true to sort of limited extent. But the other thing you have to think about is that our world is completely globally connected at this point. And so if in a larger sense, there are billions of people faced with unlivable conditions anywhere on the globe, it will be a global problem. And indeed, the analysis here has suggested that under RCP 8.5, given current trends in population growth, that something like 3 to 3.5 billion people will be outside of the preferred climate niche by 2070. And what does that mean for them? Does that mean that they will try to move? Does it mean that they will try to adapt in place? Nobody knows. Nobody wants to talk about what a world where 3 billion people are trying to migrate would possibly look like, or even such a thing can be conceived. But it's obvious that this is a global problem. So I'm going to show you a little reconstruction now, and then I'm going to quit and take questions. And it's going to start off with just showing you the vegetation across the earth today with some sort of typical circulation patterns overlaid on it. And you see the Sahara here, sub-Sahara tropical Africa here, just to orient you in case it's not coming through clearly. North America here, of course, South America here. It looks like a really nice place, right? Let's look now at the image of the Earth in terms of the human climate niche as it presently exists right now, 2020. The red areas are less suitable, either because they're too hot or too cold, and the green areas are most suitable. So we see more or less what we saw before. Large swaths of Europe are quite good, not so great here in the Gobi, not so great in Siberia. But all in all, there's a lot of green. Now we're going to change this to look at the world in 2070 under RCP 8.5. And the coloring is as before. Less suitable is red. Lots of places are turning red, and more suitable is green. Sure, there's a little bit more green up here. That's good. That's very encouraging. But look at all this red here. And keep in mind that these are very populous zones down there, much more so than up there. And that's where population is growing most rapidly. All of Amazonia becomes less desirable. Now let's take a look at where people are in the world. Less people are dark blue here, more people are white. So that's a heavily populated area in there. That's obviously heavily populated. Down here is nicely populated. South Asia is incredibly densely populated, as is all of China, but particularly this portion of there. Then there's Japan, there's Indonesia. So let's look at what the projected population density will be in places that are moving into outside of the climate niche with mean annual temperatures above 29 degrees. So blue indicates lots of people in here. We're just looking at these areas that there'll be more than 29. White is less people, but look at all these people here that are affected. And then in South America, coastal populations are pretty dense here. Interior Amazonia, not too many people. Colombia, a lot of people. So that's what that's what the world's going to look like if we don't do anything about this. There are, in fact, things we can do. For every degree of warming we can prevent 1 billion people from falling out of the climate niche. So that's a worthwhile goal if we want a peaceful world and a habitable world. I'd like to thank an organization, an NGO called Globia, there you see it, for this visualization. A few days after we published that paper in Proceedings of the National Academy of Sciences, Globia approached us and said, we'd like to do a visualization of this. Can we have your data? And yes, we were certainly very happy to do that. And you can see here some of the things, some of their other projects here. Global nonprofit dedicated to promotion of planetary awareness. Okay. Closing thoughts. Thinking like an archaeologist might actually be good for you. If you're thinking about slow processes, you can put yourself and our society into a wider context. You can make your actions appropriate given the bigger picture. One of the things that archaeologists understand that I think most people really don't understand is that our condition today is completely non-representative of the human condition throughout the entire past of the world as far back as archaeologists can document. We are much more numerous and much more networked than we have ever been. We are much more wealthy than we have ever been. I'd like to develop a talk just on that. But we also have wealth disparities that are on the high end for what seems to be usual in world prehistory. And finally, as we just saw, we're changing the planet to a degree that's completely unprecedented, with results that can barely be glimpsed but do not appear to be pleasant. So think about slow processes and make your actions appropriate given the big picture. That's all. Thanks.
Thank you so much, Tim. It's one of the most amazing talks I've ever heard.
Mark, I think you're muted.
I unmuted. Can you hear me, Taylor?
I can hear you. I think Tim turned off the sound on his computer when he played that video. So I think that it's the sound on Tim's computer that's causing it to not come through. Can you see the closed captioning, Tim?
I don't think he can hear you either.
All right, let me give.
Can you hear me?
We can hear you. You muted us on your computer. You'll need to turn the volume back on.
Mark, I cannot hear you.
I'm going to give him a call on his cell phone.
There we go. Got it.
Okay.
Can you hear me now?
Yes.
Good. Tim, I was just thanking you for your talk. And it's rare that we get archaeological talks that incorporate data from around the world and look at our really deep millennia-long history as a species and project that into the future. So it's just such a thought-provoking talk. You might have somewhat blown people away because there's not a lot of questions, but we do have some. So I'm going to start with one that asks, are there any, this comes to the first part of your talk on inequality. Are there any examples of high inequality moving in reverse back to lower inequality? If so, does this happen quickly, like a collapse, or slowly? And how long does it last at the lower inequality situation?
Yeah, that's a really wonderful question. And there's a fellow, a Stanford historian named Walter Scheidel, who has written a book on that in 2017 and examined this going back all the way to classical antiquity. And he concluded that there are really only 4 things, or more or less, that can cause big declines in wealth inequality. And this is a rather pessimistic conclusion because all these are terrible things. One of them is pandemics. So the Black Death caused a large decrease in wealth inequality because there were many fewer people in Europe, and the people who remained could demand higher wages for their labor, and so wealth inequality declined. And if you have famines or global conflict, all those things can destroy wealth inequality and make conditions more equal. But you wouldn't want those to happen. So the question is, how can wealth inequality decline without a soul-killing catastrophe of some sort, which probably ordinarily results in large-scale death? And I suppose you could say that maybe the Scandinavians have part of an answer. Their wealth inequality levels are on the order of 0.5, maybe 0.6 in that vicinity. And so where we have relatively unchecked capitalism, like in the United States and Great Britain to some extent, wealth inequality is much higher. So there's really fundamentally only two things that affect the potential, how high wealth inequality can go. One is the amount of surplus. The other is how that surplus is distributed. And so political actions, the political economy, how that's structured, whether taxation is regressive or progressive, those things can affect it. But according to Scheidel, they affect it primarily at the margins. So this will be small-scale tinkering that we can achieve with things like tax policy.
Well, Tim, when I think of examples in the past in areas where I've worked, and I'm not sure this is right, so I want you to correct me if I have just a too simplistic understanding of these societies, but I think of one, the Maya region, where it did go back to a less inequality at the end of the classic Maya period, and yet that society persists into the present. There's millions and millions of Maya people, and what disappeared in that society was the people more on the highest end. The highest end wasn't as high as after the classic period. And I wonder if even in the Southwest, the Chaco period to the proto-historic Pueblo period is another example.
Yeah, I agree with both of those, Mark, but I wouldn't say that those were costless either. The elites did disappear at the end of the classic Maya, and probably a lot of them died. Maybe some of them moved northish, but it wasn't, for them at least, it wasn't costless, and there was probably a lot of depopulation and a lot of death involved with that. Now, for the Puebloan case, you know that as well or better than I do, and we know that there was a lot of conflict in the 1200s. We know that people were eating a diet that by that time was not very healthy, and so there was probably a lot of unhappiness and suffering, and frankly, some people probably did not make it down to places like the northern Rio Grande or Acoma or Hopi or Zuni. Probably they perished along the way or never got out. So I would say that both those examples are relevant, but I don't think that those are entirely examples of a peaceful, happy transition to lower wealth inequality.
Yeah, thank you. I have a question that says, from 10,000 BC to 100 AD, are there general patterns of wealth inequality, house size, development of social complexity that can be teased out with the Gini indices?
Well, as you saw in that blue line, just remembering what that is, it was very gradually, slowly mounting. And Walter Scheidel contends that in a stable society, or a relatively successful, stable society, that what will happen inevitably is that wealth inequality will either remain stable or it will increase. And so I think that you can see the general success, despite huge amounts of warfare and population movement and technological innovation in that scenario. On the average, wealth inequality was increasing, and that's what that graph showed. And so that is the big pattern, but what we can see when we break it up and look at particular regions in more detail, and we've done this, And Mark, you're aware of this work with the Pueblo sequences. We see that there's a lot of up and down in wealth inequality in a particular region. So it just looks smooth when we look through the macroscope and look at what's happening in the old world as a whole. But if we could look at any particular region, I think we'd see a real graph of lots of up and down that has to be explained, and that will be a job for local archaeologists to do. But the big pattern is fairly clear.
Yeah, thank you. Are there any studies that overlay political and or social organization over the data you presented? Is there evidence regarding how people are ruled or rule themselves, which has an impact on the outcomes of their civilizations?
Wonderful question. Let's go back to this graph here. Oh, maybe, never mind, it's too hard to do that. Let me just say that, yes, there is an impact of how people are ruled. And this has been realized for some time by multiple researchers, including people like my co-author, Mike Smith, who has claimed, along with others, that in situations where the rulers are relatively despotic and excuse me, don't rely on their population for taxation, but rely on external trade or other external sources for their legitimacy, they tend to be more unequal than societies where the rulers are answerable to their population, which are more democratic, which are more coordinative and less despotic. And one example that went by too fast for you to see it perhaps is Teotihuacan in that slide that I showed. Teotihuacan is an interesting site because it doesn't show much of the sorts of evidences that you would normally expect for despotic rulership. That is, you don't have lots of images like you do in the Maya area for the ruler and lots of text about how magnificent the ruler is and all those sorts of things. They don't even have, last time I tuned into the archaeology of Teotihuacan, they don't even have any burials that look as though they could have been burials of a ruler. And that's certainly not the case in the Mayan area. It's the exact opposite. So Teotihuacan has a very low Gini. In fact, Mike Smith has recently revised that upwards, but it's now, I think, under his current revision, it's around 0.2. So for a state, that's remarkably low. And most states are more like 0.4, 0.5.
Maybe that's why it lasted for 700 years.
Yeah, perhaps. The people were happy.
I have somebody asked, do your findings on wealth inequality point to humans being innately greedy?
Well, I think that people are innately greedy, and I think they're innately interested in getting along with other people too. We have both of those tendencies that are built into us, and they're always fighting with each other. That's why we can have societies that express themselves as fairly democratic societies with relatively low wealth inequality, and why we have other societies that are just the opposite. So these are not, in my view, in any sense triggered by our innate tendencies, though they find themselves in line with our innate tendencies in different situations. So I wouldn't say our biology is driving any of this, because the biology is not changing on the timescales where we see the Gini's changing.
This is something of a tangent, but I was involved in a edited volume that Monica Smith organized called The Archaeology of Abundance. And the point that she made is most modern economists study economy in terms of the principle of scarcity. And she made the argument that the archaeological record, you could use the archaeological record to argue that humans seek abundance, and perhaps not in a greedy way, but so there's a slight difference between seeking abundance and greed. So I'll leave it at that and move on to the next question. Thank you for a great talk. This is from our colleague, Tom Rochek. Hi, Tom.
Hi, Tom.
Thanks for tuning in. Thank you for a great talk. With the climate niche discussion, what happens when you add rainfall into the niche over time? I'm guessing the picture gets worse.
Tom, I refer you to the article. There is, in fact, in the supplemental information, we replicate the analysis that I showed you just now, but with precipitation. And we also replicate it showing different levels of warming, that is, from the least degree of warming that can be imagined, which is, I think, what, 3.1, RCP 3.1 or something like that, on up to 8.5. We show three or four different levels. And we also show the precipitation. The reason I didn't show the precipitation is that the picture is a little bit more complex, but overall, if you squint, the picture is still pretty much the same. So the areas that are going to be much less habitable under RCP 8.5 in 2070, even when we factor in precipitation, are going to still be pretty uninhabitable. Good question, though, and I hope you'll take a look at the article.
This is related, but I think slightly different. A person asked, have you cross-referenced these temperature findings with access to water?
We have not done that, so I can't really predict what the answer would be. Clearly, in some places that are relatively uninhabitable now, like the Sahara, access to water is almost entirely absent. But in other places like Amazonia, access to water is not an issue. In fact, if anything, there's too much water. So I don't know how to answer that question, Mark. I'm sorry. Off the punt.
Thank you. Another question from one of your longtime colleagues and one of our best friends, Richard Wilshusen.
Hi, Rich.
Tim, I know you've studied crises and collapses as a part of your study of change. There's a saying that you never want to let a good crisis go to waste. What are examples of societies that did not let the crisis go to waste?
Well, when we look at the Pueblo sequence from 600 to 1280 up in the central Mesa Verde, I suppose you could argue that there were some crises that were not let to go to waste, because what happens there, as you know, Rich, and Mark knows as well as I do, is that typically during good times you have villages form, and as villages form and people grow in local areas, inevitably, although not in every area, but that's a detail. But the big picture is that wealth inequality tends to increase during those periods. And then the ends of those periods, like the end of Pueblo 1 around 900, the end of Pueblo 2 around 1140, and in spades, the end of Pueblo 3 around 1280, all of those represent periods where you have a decline in inequality. So if you think that inequality is the worst thing in the world, then these crises at the end of each of the standard Pecos periods are examples of crises that did not go to waste.
Thank you. There's about 4 more questions, and then I'm going to stop. We're over our time, but this is so interesting. I'll just let people leave if they want to, but I'm going to continue and ask these 4 that are left. One is wealth inequality simply a byproduct of evolution and development?
Well, first of all, I would say there is a sense in which that's true, and I don't want to deny that. For example, there was a very interesting study that came out a couple years ago in which a researcher showed what happens with inequality in shell sizes for hermit crabs. And he showed that hermit crabs actually develop a Gini of around 0.3 if they're left to their natural processes. And what that is of course, measured across shell size for the hermit crabs. So these hermit crabs are not, they're not greedy. They're not, any more than any living thing is greedy. All living things are greedy in the sense that they want to eat, they want to reproduce. They want to maximize their reproductive success. And so people try to do that. So part of maximizing reproductive success, if you're humans, is probably increasing your wealth inequality. And some people are able to do that more successfully than others. And so that does increase wealth inequality through time. So there is that sense in which it's sort of like a natural process. However, the fact that we have cases where the political economy, the nature of the political economy has seemed to change radically the achieved Ginis in some societies like Teotihuacan, shows that there are countervailing forces as well that can radically affect the degree of wealth inequality that people are free to achieve.
Thank you. Does increasing intensity of agriculture signal increasing elites and thus wealth inequality?
Generally, yes. If you look at the average Ginies for hunters and gatherers, it tends to be pretty low, like around 0.2. If you look at it for horticulturalists, extensive agriculturalists, and gardeners, it tends to be around 0.3. And if you look at intensive agriculturalists, it tends to be around 0.4 or something like that. So that is the tendency. And the reason that that tendency is there has to go back with what I said about the two factors that underlie potential degrees of wealth inequality. And those are the degree of surplus, the amount of surplus, and how that surplus is distributed. And as you move up that scale from hunter-gatherers through horticulturalists to intensive agriculturalists, you're increasing the amount of surplus, or potential surplus anyway. So there is that tendency. But then once again, how the surplus is distributed will radically affect the nature of the Gini that's achieved in many of those societies.
Thank you. We got three more, so hang in there, everybody. Will human biology change with climate change?
I don't think so. Human biology changes on very slow timescales. The kind of adaptation we can do to climate change is going to be cultural adaptation, technological adaptation, and maybe even mitigation. Perhaps we'll find ways of sucking carbon dioxide out of the atmosphere. In fact, we know how to do that right now, but it's very expensive to do so. And so it doesn't look like a very profitable way to proceed. It looks like it'd be much better to not put carbon dioxide into the atmosphere in the first place than try to suck it out. So I don't see biological changes as happening. The timescale is too short.
Yeah, that's what I would argue too. Your answer to that question relates to this question, which is, couldn't future climate change also drive technological responses? And couldn't we envision more cities like Phoenix in the 2070s that, apply technological, I'm not sure solutions is the right word, but mitigations to the climate change?
Well, I don't want to offend anybody, but I would not want to live in Phoenix in 2070 under RCP 8.5. Yes, technology is obviously a factor. Just take the case of Florida. Florida was relatively lightly inhabited until in the 1950s, air conditioning became much more common. And all of a sudden, there was a land rush in Florida. It became a nice place to live. That is, people could achieve their desired climate niche by staying inside and having air conditioning. So technology made Florida a nice place to live. And swamp coolers do the same for parts of Phoenix and Tucson, I think. So will there be technological, I think the larger question is, will there be technological innovation that make it so that the climate changes we're forecasting under RCP 8.5 will not be a problem? Perhaps, but I would hate to count on it. I would think that at best, the technological innovations that we'll see will be at the margins. If you remember that for one of the early graphs I showed, the relationship of crop production to mean annual precipitation and mean annual temperature, sure, we can use all sorts of techniques now to try and enhance the production of grains under higher temperatures and under different precipitation regimes. But at some point, there's got to be a limit to that. Maybe we don't know quite what that limit is, but we don't want to find out what that limit is and find out that, well, guess what? We're already beyond that limit in some of the places that are most in trouble. So I think it's a really dangerous proposition to count on technological innovation to dig us out of the climate change problem that we are getting ourselves into. But there's undoubtedly technological innovation that can help. And just look at the switch that's happening now with incredible speed for going to electric vehicles, which is obviously, electric vehicles have been around for a long time, but the new ones are a lot better than they were 100 years ago. So,
well, I'd point out that this debate that we're talking about right here is decades long. And I don't know if you remember in the 1980s, but there was a really prominent economist that was influential in the administration then, who published a popular book called The Ultimate Resource. And the ultimate resource was human ingenuity. Mm-hmm. And he basically argued all you doomsdayers are discounting our ability. So that is sort of a dangerous thing. If you thought of it as a poker game, it'd be a dangerous bet to make. Okay, two more. One of them disappeared. I think I didn't get to it, so I'm sorry to that person if I missed it. Will population growth outstrip our resources?
Well, here I'm slightly less pessimistic about that than I am about what will happen to the population distribution in the world under global warming. We are extremely technological innovative, and so I think that we have shown that we can produce massive amounts of food. You know, for every farmer in the United States, every farming family in the United States now produces enough for something like, and I'm sorry, I've forgotten the exact number, maybe 190 families or something like that. So that's the potential surplus that I was talking about, which is one of the things that can affect the Gini's. And that's one reason we have very high Gini's in the world today, is our potential surplus is very high. Of course, in other places in the world, people are subsistence farmers and they barely produce enough. So kind of lost the thread of the question here. Oh, are we going to run out of food because of population growth? I think we're going to run out of food in particular areas, and this distribution of food will be a major issue, and our distribution systems will have to be better than they are now. But I would hope that we're not going to run out of food anytime soon.
That's interesting, because I was going to ask the question earlier about, have you thought about other ways to measure inequality besides house size? I guess when you're dealing with the past, it would be hard to come up with, I mean, you could measure inequality, but not inequality per capita. But in modern times, you know, access to food and what kinds of food is certainly a measure of inequality. Okay, two more. Thank you, everybody who's wanted to hang in there. Somebody asked, are you sharing this climate information that you're producing with John Kerry, the new climate czar?
I met John Kerry once at a Boston Marathon where a friend of mine was running, but that was about 20 years ago, and he's not going to remember me. So no, I do not have the connections to do that.
So who does read this volume? What is the potential impact of this volume that you're working on with your colleagues?
Well, first of all, I would say that Proceedings of the National Academy of Sciences publication got a lot of attention. And so I would think that I would hope that people are going to see that, and perhaps it's even crossed John Kerry's desk, although I have no way of knowing that. If I had an avenue into his office, I would be happy to send it to him, and I would love to go talk to these people. But I do not have those entrees at the moment, unfortunately.
Okay, we're going to end with a more human question, which is, how did you get into archaeology and these areas that you specialize in?
Well, how does anybody get into anything? I think that I was always interested in archaeology as a kid. So I grew up in Davenport, Iowa, and across the river, across the Mississippi from there in Rock Island, Illinois, there was a neat little museum about Black Hawk and his times and the prehistory of that area. And I would always want to hang out there and bored my father to tears. We can't go to this museum again. We just went there 2 weeks ago. So I've always been interested in this stuff. And I read everything I could get my hands on as a kid that was intelligible to a grade school kid about archaeology. So then in high school and college, I kind of thought, well, this is totally impractical. I'm not going to do it. I don't know what to do. And so I shopped around all sorts of majors, and I ended up being a general studies major at the little liberal arts school I went to as an undergraduate, which turned out to be fine because you don't want to be too specialized as an undergraduate. And then finally, as a senior, as an undergraduate, I decided, well, I'll give archaeology a try. And it was back in the days in the 60s and 70s when students didn't worry too much about making a career of it. I didn't ever ask myself, can I make a job out of this? I just did it because it sounded interesting. And that's the kind of thing that people did back then that I don't think students do very much now. And I kind of regret that. Why I got into these particular areas, I think because in part I saw them as not being addressed by other archaeologists. So I saw them as an empty niche, and I thought it was a niche that was important. I wanted to fill it, so I moved in those directions.
Well, we're glad you did. It was you've made incredible contributions to our understanding of ourselves as human beings, and not only where we come from, but where we're headed. So,
well, thanks so much. Thanks so much, Mark, and thanks to all of you who hung in there. That's really good. I'm proud of you. There were dry portions there, and a lot of you are still there. Thanks a lot.
We still have 100 people. So thank you, everybody. We'll see you next Thursday.
Okay, bye.
Bye.